Okay, is anyone else uncomfortable with induction? If so, you're definitely not alone. Um, Formally, that feeling is called Hume's problem of induction. Um, Most basically, that problem is that past behavior isn't a perfect predictor of future behavior. Just because it rained every day last week doesn't mean that it's going to rain tomorrow. Maybe it will, maybe it won't. Maybe it more probably will, but we're not sure. And philosophers, logicians, and mathematicians like to deal with sure knowledge, not general, probablys. And so philosophers didn't like induction. David Hume brought this preference to an extreme. He would do things like point out, well, past behavior isn't a perfect predictor of future behavior. So just because every time the sun set and it got dark, every time that happened in the past, about 12 hours later the sun came up again, past behavior doesn't perfectly predict future behavior. We don't know that tonight's not our last sunset and it won't stay forever dark after that. We don't know that the sun will rise again tomorrow. Okay, prove it to me. How do you know the sun will rise again tomorrow? Oh, just because it always has in the past? Well, we have lots of examples of future behavior not following past behavior. It might have rained every day last week, but that doesn't mean it'll rain tomorrow. Or the black swan example, just because at some point in some country, every swan they had ever seen was white, doesn't mean there isn't a black swan out there somewhere in Australia waiting to be discovered when the British sail around the world to Australia. There could be a black swan out there. Past behavior doesn't prove future behavior. So you don't know for certain that the sun will indeed rise tomorrow. If all you have for evidence is that it will, is that it's always done that in the past. Hume was not being, super serious. If he had stuck by that philosophy, then basic everyday decision-making would be impossible. How was I supposed to know that objects fall down just because they've always done that in the past? So Hume was being a little playful, but he was hitting on a major question. I think we've answered Hume's question, not in the course, just in real life. And the answer is basically statistics. A whole field of mathematics had to be invented to solve Hume's problem of induction. And statistics is only a few hundred years old. It's maybe 100 years less old than Hume himself. I guess Hume now would be about 300 years ago. Statistics, good statistics is only about 100 years old, but a lot of the basics went back to the day of Hume. But still, 300 years ago, that's very recent in the big span of history. Aristotle's 2,000 years older than that. So there was a long time where we still had philosophy, but no one had a solution to Hume's problem of induction at all. Is that important? Actually, I think it is pretty important. For most of antiquity and the Middle Ages, at least in the West, philosophers really didn't trust induction. Like, we had logic and philosophy, and even pretty good math, long before we started to invent science. Why that gap? Like, if you look at the history of ancient Alexandria at the end of the Greek Empire, there were some people doing science. Aristophanes of Syene calculated the circumference of the Earth pretty correctly from an experiment. Induction. He was comparing the lengths of shadows. It's sort of a long explanation, but with shadow length comparison, looking at real-world data, and making analogies and extrapolations based on real-world data, inductive reasoning, he basically figured out how big the Earth was. And a very primitive version of the machine that started the Industrial Revolution, the steam engine, at least a very primitive version of that had been invented by Hero of Alexandria in about the same time, right around 0 AD-ish. But an industrial revolution didn't take off in ancient Alexandria. Empirical observational science really didn't take off until much later. So this preference for math and deduction held civilization back. That divide, at least in ancient Greece, is seen between Aristotle and Plato. Plato very much was a math kind of guy. He cared about the abstract, eternal knowledge, and wasn't a big fan of observation or deduction. His student Aristotle was less dogmatic. A famous painting by Raphael, 2,000 years later, Plato and Aristotle, and Plato's like pointing up, he just cares about the abstract world of the heavens, whereas Aristotle actually points towards stuff in front of him on the ground. Hey, look at that! Plato wanted to get to knowledge through pure deduction and math. Like, he even wrote on top of the doorway to his school, "Don't come in here if you don't know geometry," or something like that in ancient Greek. Whereas Aristotle thought that looking for patterns in the real world and then reasoning by analogy was a viable way to get to the abstract knowledge that Plato wanted to reach directly. Aristotle's perspective became the foundation of science, but as far as who won the debate, basically the Platonic perspective won the debate in the ancient world. Even a little later, when the Christian religion became dominant in Europe, it fit better with Plato's way of doing things. Plato would look at like abstract math, whereas the Christians would put God in that position. But whether abstract math or some old ancient guy outside the universe, they were both trying to have direct knowledge of something that's outside the physical world. So in the in the Christian tradition of the first millennium, Plato's way of doing things stayed dominant. Aristotle started to come in a little later. His works were held on to by the Arabs, and eventually it got retranslated back into Italy. And later on, Aristotelian philosophy started coming into Christianity, and we get a shift from the style of St. Augustine, who was very much in the lineage of Plato, to the style of Thomas Aquinas, who was more of an Aristotelian. And that basically sort of still went almost nowhere. Until about the year 1600 with Galileo. Galileo practiced what Aristotle slightly preached. Galileo would actually do experiments and actually look at things. Even look at things with the newly invented telescope. By today's standards, it would just be binoculars, but they just figured out how to grind glass into lenses and string the lenses together in a pipe. So they had really more like a pirate spyglass, but they sort of had invented telescopes. Galileo got one, and now he's looking at all kinds of things. And he's a little confused by what he sees. Aristotle had a version of physics where it's basically 4 elements, a lot like Wuxing. Okay, 4 or 5, close enough. And he had a very primitive idea of physics. So then Galileo started, dropping rocks out of windows and seeing if what he saw matched what Aristotle said he should see. I think Aristotle predicted that rocks would fall at a constant velocity, whereas Galileo saw them falling at a accelerating velocity. And it wasn't even close. Stuff just was not matching. And it wasn't just 1 or 2 isolated things. Galileo also looked at the sky and looked at the celestial bodies at night. And the dominant theory at that time was that everything else in the solar system orbited the Earth directly. So then, that was Ptolemy's theory. Ptolemy was one guy in ancient Alexandria. And 2,000 years, or 1,500 years later, they were still stuck. They were still going by what Ptolemy said. Mostly because a lot of the things that in ancient Alexandria were just popular theories, that's the best knowledge we have at the time, became adopted by the Christian religious establishment, and they weren't very good about keeping differentiated which things were core dogmas, very, very important beliefs. We hate you and will attack you and kill you if you don't believe them. Very important beliefs. Versus just random other guesses about how we think the world works. Not things we believe, probably, but they're just sort of guesses. Very important beliefs and random guesses sort of got mixed up a bit. And so the Ptolemaic view of the solar system ended up getting missorted from random guess some people thought, best guess we have, to major belief. And so Galileo gets his telescope and he's like, I'm not exactly sure what's happening, but it doesn't look like what Ptolemy said. He's looking out at Venus, and he sees Venus, like, going in front of the sun. He's like, wait a minute, Venus is going around the sun. It's not them both going right around us. And he sees the same thing at Jupiter. Apparently Jupiter has its own moons. There are these little things going around Jupiter. He's like, wait a minute, they're supposed to all be going directly around us. Granted, for all he knew, maybe those little Venus and those little moons of Jupiter were satellites of the Earth. He didn't disprove that hypothesis. That didn't fall apart until Newton. But even though Galileo didn't really know what was going on, he made it pretty clear that the wisdom of the ancients and the old holy books was not necessarily exactly right. I don't believe it. Just look at the telescope. Look at it. Look at the dropped rock. Aristotle was just wrong. And he started making a lot of discoveries that sometimes the ancients were clearly wrong. And Galileo didn't really have his own big philosophical and mathematical theories. He was more just doing experiments and induction and just looking at how things moved in the physical world. Very primitive stuff. But that inductive method of looking at the real world and doing observation had been neglected for so long that there was a lot of low-hanging fruit. Like, you think in 1500 years someone would have noticed that Aristotle was just plain wrong about a few things in physics, but people just hadn't been in the habit of taking induction seriously. The world's chaotic. Past behavior doesn't always guarantee future performance. But so they didn't even try. Then Galileo tries, and wow, there's a few obvious things that are wrong. Of course, for him, it became a giant court case. His attacking of the Ptolemaic system of the solar system became seen as an attack on the authority of the religious establishment, and he got into big trouble for that. It was sort of a surprise, too. Like, initially, even Galileo didn't come up with his own theory. He basically provided experimental data to say that Copernicus's other theory was correct. And Copernicus lived like 100 years earlier. And apparently the church didn't have a problem with it. But then with Martin Luther and a bunch of wars and stuff, the situation of the church got a lot less secure, so they became a lot more sensitive to new changes that could undermine their authority. And Galileo ended up making a new discovery that undermined authority at a bad time. And so he ended up with this giant court case, inquisition, house arrest. Became sort of famous, though. And so his method of natural philosophy, discovering stuff not by deduction and math and logic, or not exclusively by logic, but by actually going out and observing and testing things, the more infamous Galileo became, the more widely his method became known. However, Galileo didn't really settle Hume's problem of induction. Hume lived a century after Galileo. Like, Hume knew all about Galileo. Galileo was wrong about a lot of things. He found some situations where the ancients were clearly very wrong, but Galileo wasn't himself correct about a lot of things. First, he didn't falsify the Tychonic model of the universe. He didn't prove Copernicus over Tycho Brahe, or a small detail. But moreover, Galileo was wrong, dead wrong about some things. He thought that that everything in the solar system went in perfect circles. Turns out that circles are very rare. Really, things move in ellipses, like these round egg-shaped orbits. It was actually Tycho Brahe and Johannes Kepler who figured that out. And it only made sense once you get to Newton, decades later. So Galileo, for all his good things and good discoveries where he proved someone else wrong, he was himself wrong about some things, like the shape that of the orbits of the planets. So it was an open question about whether observation and induction can actually generate new certain knowledge, or if all it's good for is checking and tearing down false knowledge. So 70 years after Galileo, Hume's problem of induction still stands. How did we solve it? Because for 2,000 years, we're 2,000 years past Aristotle, and not much progress has happened. Little Galileo, but still, that's not much for 2,000 years. The solution didn't really come from the philosophers and the academics. It came from somewhere else, and then we repurposed it. So the problem with induction is randomness. The world's sloppy. You measure something once, it's one measure. You measure the next thing, it's a little different. The real world's sloppy. It's random. And Plato and friends were very uncomfortable with that randomness. Induction became habilitated when humanity got more comfortable with the randomness. So, anyone dealing with randomness? Gamblers. So, we're in France in about the 1600s. There are rich nobles, but there's no internet, there's nothing to do. So you have people who have wealth, they don't need to work for a living, but they get bored. What do? Mostly they do a lot of gambling. They play with each other a lot of games that involve cards or dice. Things that involve randomness. Yeah, controlled randomness, but still randomness. You don't know which card's going to come up next. Not exactly. You don't know what the dice roll is going to be. Well, I know it's going to be an integer between 1 and 6, but I don't know exactly what it's going to be. And people were pretty competitive about gambling sometimes. Sometimes they didn't want to lose their money. Sometimes they wanted to beat their friends. So these rich French noblemen had a reason to want to become more successful gamblers. And gambling, it involves numbers and uncertainty. So some of them started trying to war game dice rolls. Okay, there's 2 dice. I can get a number between 1 and 12 for the sum. How many ways could I get a 12? How many ways could I get a 1? How many ways could I get a 7? How many ways are there total? They'd start trying to plan out the possibilities of gambling. And usually they'd get tired, and it's a lot of math. But luckily they were rich, so they could just hire a mathematician to crunch the numbers for gambling math. And so the French nobleman pays some mathematician to figure out the math of gambling and tell him and explain gambling math to him so that the next time that guy's gambling, he can gamble better than his friend who doesn't know gambling math, and he can win and beat his friend. And after a while, the gamblers and the mathematicians that they were paying had actually sort of figured out the theory of dice and cards. They'd sort of figured out gambling math. And the secret ingredient, the magic step, was when people decided to start applying gambling math, formerly known as probability theory, to other things, to other uncertain things in the world besides dice and cards. So these guys are French noblemen. They sort of own the country. They sometimes had to do statistics. Now when we hear the word statistics, we generally think of a lot of probability theory. But people were trying to do something called statistics before the invention of probability theory. Back then, well, if you look at the word statistics, S-T-A-T, it looks a lot like the word state, S-T-A-T-E. Indeed, statistics is related to the word state. Statistics was originally the goal, the enterprise of measuring the state, doing a bunch of counting all the people, counting all the grain production, counting all the taxes, counting. Too much counting. Sometimes we can't count everything, and we need to guess, or there are unknowns. So the owners of the country are trying to count things, but at some point they start running into gaps in their data. This guy just didn't collect the data, I just need to guess. They're dealing with uncertainty. And then they notice, I've dealt with uncertainty before. I dealt with it at the gambling table. Okay, I want to make good guesses about the state of my country. Not just complete random guesses, I want good guesses. Well, what if I take my book on gambling math and apply gambling math to the gaps in my data in my state measuring? Probability theory, measuring the state, modern statistics. So eventually people started applying gambling math, probability theory to other things. Measuring the state, or to experiments. And with that, they became so good at it that they were able to measure, delimit, and even quantify uncertainty. They could put numbers on how uncertain they are about something. Will it rain tomorrow? I think so. Probably. They were able to not just have maybes, not just have probably, probably not, adjectives. They were able to put precise numbers on how sure or unsure they were. And so with gambling math, now the floppy world of experiment induction actually looks a lot like math. stuff that philosophers and logicians can deal with. And so with good statistical tools, we can get fairly good knowledge out of variable, sloppy real-world data. We can elevate observation, induction, the stuff Galileo was doing, almost to the level of certain knowledge like deduction. And that is the scientific revolution, which is basically the reason that technology, economy, and prosperity have increased a real lot in the past few hundred years. Most of history, it's getting a little better, and then a few hundred years ago, it starts taking off. That's basically due to the scientific revolution, which is Galileo's rehabilitation of inductive reasoning, then with gambling math, probability theory on top of it, so we can be sure, or pretty sure, about the stuff that we observe. Yep, that's the foundation of the modern world.